Welcome to LIB Academy. In this video, I'm going to take you through gamma functions and why the need for us to study gamma functions. Gamma functions help us to evaluate integral problems with ease and most importantly, improper integrals. So before we continue with this video, there are some formulas we need to know. In this video, we will not be proving them. If you want to know how to prove them, you can check those videos out too. So let's continue. The general gamma formula is of the form gamma n equal integral from 0 to infinity x to the power n minus 1 e to the power minus x dx. So this is the general formula for gamma functions, where our n here is greater than 1, and this function is convergent when n is greater than 1. So there is a need to keep in mind this formula very well. And we have gamma of n plus 1 equal n gamma n. That is another formula you need to know. Gamma of n plus 1 should also give us n factorial. Like I said earlier, we are not going to be proving these formulas in this video, but you can check those proving out. Another formula you also need to know is Euler's formula. Euler's formula, gamma of n multiplying gamma of n 1 minus n should give us pi over sine n pi. So those are few formulas you must know as far as gamma functions are concerned to be able to solve such problems, including another two constants. So gamma of half is going to give us square root of pi. So this is a constant, and gamma of 1 is going to give us 1. Now that you know these formulas, we can start solving problems. Evaluate the following. We have gamma of 7, gamma of 8, gamma of 4. Now to solve this problem, we have to look at a corresponding formula that we can be able to use and solve a problem like this. So the formulas that we can easily refer to are, if we have gamma of n plus 1 equal n gamma n, and gamma of n plus 1 equal n factorial. Now the difference between these two formulas is that we use this formula 1 here if we are dealing with fractions mostly, and for this one if we are dealing with a single number, I mean a number which is not a fraction. So now let's continue. Now solving problem like this using this formula right here will make our work more easier. So just keep it in mind. If you have a problem like this, you have to use this formula, but where fractions are involved, you use formula 1. So gamma of 7, we are looking at a way of breaking this number in such a way that it will be 1 plus something, which will give us 7, so that we can use this formula right here. So you could see that 6 plus 1 is the same as 7. So gamma of 6 plus 1, if we break it this way, we can use this formula and evaluate it. But why not 7 plus 1? You could see 7 plus 1 is going to give us 8, which is more than this, and we are not supposed to do that. We have to break the value that is given in the 2. So 1 plus something should give us this value. 6 plus 1 is 7. So we can therefore go ahead and say 6 plus 1 to give us, comparing this formula to this problem right here, our n is 6. So it's just going to be 6 factorial. Yes, 6 factorial. So 6 factorial, punching it on your calculator will give us 720. Now let me go over this once again. Now we are able to break the number into something plus 1. And comparing this formula, n plus 1 equal n factorial. Our n here is 6, right? You can see our n here is 6, so 6 factorial. So nothing changed. Now the second problem is gamma 8. So gamma 8, we want to use, like I said earlier, because it is not a fraction, we are using this formula, right? So gamma 8, we want to find a way of breaking it into 1 plus something to give us 8. So you can see that 7 plus 1 is definitely 8, right? So right here, 7 plus 1 should be equal to 7 factorial, right? Comparing this formula to this, our n right here is 7, and then which is 7 factorial. So 7 factorial here will give us, that should be 5040. And then our last example on under this is gamma 4. So gamma 4, we want to find a way of breaking it into 2, should be 3 plus 1. 3 plus 1 is the same as 4, right? So we can therefore go ahead and say gamma 3 plus 1 equal 3 factorial. And 3 factorial is the same as 3 by 2 by 1, which will give us 6, right? So now find gamma 3 on 2, gamma 5 on 2, gamma 11 on 2. We need to know these basic things, these basic examples before we can go further, because we'll be using them in our subsequent examples. Like I told you earlier, when you are dealing with fractions, just keep this formula in your mind. This formula is going to be used. So gamma 3 on 2, how do we solve this? So we want to break this one in the form n plus 1, gamma n plus 1 to be equal to n gamma n. And now that we don't know what we should add 1 to give us 3 on 2, we can simply form a basic equation and solve for value of n. We need a number to add 1 to a so that it will give us 3 on 2. So if you can guess the number and it is right, then you are okay. If you don't want any trouble to, because we need something to add 1 to 8 to give us 3 on 2, you can say, oh, n plus 1 to give me 3 on 2. I don't know my n. So let me solve for n. Simplifying this equation, let's multiply 2 by 2. So 2n and 2 by 1 should give us 2, and 2 by this will definitely give us 3, because when we multiply 2 here, it will cancel. So now let's make n the subject. So 2n equal 3 minus 2. And at the end of the day, you are going to see that we will have 2n equal 1. So dividing both sides by 2 to solve for n, our n equal half. So now that we know that n equal half, it means half plus 1, it will give us 3 on 2. You can check that on your calculator. So now that we know that half plus 1 can be okay, so we know that gamma 3 on 2 is equal to gamma half plus 1, then we can go ahead and apply this formula. So gamma half plus 1, comparing it to this formula, our n here is half. So it's going to be half gamma half. So half gamma half. And we know that gamma half is a constant, square root of pi. Anytime you see gamma half, it is square root of pi. So we are going to get half square root of pi. So this can also be written as square root of pi on 2. So this will be our final answer for this problem. So now example number 2, find gamma 5 on 2. How do we solve this problem? Don't forget that it's a fraction. So we are definitely going to use a formula like this formula. So we are looking for some number that we add 1 to, and it will give us the same 5 on 2. What number can we add? We need n plus something to give us gamma of 5 on 2. So in order not to confuse yourself, we need something to add to 1 to give us 5 on 2. So just form a simple equation and solve for your n. So you can say n plus 1 to give us 5 on 2, like we did in the previous example. So multiplying through by 2 to solve for n. We see that 2 by n, 2n, 2 by 1, 2 equal 5. If you multiply here by 2, 2 will go away. So we are going to get 2n equal 5 minus 2 crossing become minus. These 2 crossing the equation become minus. So we are going to get 2n equal 3, right? So dividing both sides by 2 to get our n, we are going to see that our n equal 3 on 2. So now we know that 3 on 2 plus 1 is the same as 5 on 2. So gamma 3 on 2 plus 1 is the same as 5 on 2, right? So what is the problem again? We are solving for gamma 5 on 2. So gamma 5 on 2 is the same as gamma 3 on 2 plus 1. So now that we are able to express this in this form, then we can go ahead and solve for gamma 5 on 2. So gamma 3 on 2 plus 1, sorry, this will be plus 1. Comparing this to our general formula, this formula, you could see that our n is 3 on 2. This formula right here. Like I told you earlier, with fractions, we'll be using this. So comparing this to gamma 3 on 2 plus 1, let me write this so that it will be clear. Gamma 3 on 2 plus 1, you could see that our n now is what? 3 on 2. So this is going to give us n gamma n. So 3 on 2 gamma 3 on 2. So now we are supposed to do this up to a point that you will get a constant, or up to a point that if we are to go further, you'll be getting some value which is difficult to express, and to simplify, then you leave it. So this means that we have to take gamma of 3 on 2 again. You have to solve that one again. So we know that this gave us 3 on 2 gamma 3 on 2. So we have to simplify gamma 3 on 2 further. So now we have to look at a certain fraction that we add 1 to, and it will give us 3 on 2. And to do that, let's form our basic equation, solve for that. So we need a certain value, n plus 1, which will give us um, gamma 3 on 2, right? Or we need n plus 1 to give us 3 on 2. Let's focus on this. So n plus 1 to give us 3 on 2. We need some value that we add 1 to, so that it will give us 3 on 2. So simplifying this, let's multiply through by 2. So 2n multiplying 2 by 1 gives us 2. Multiplying this by 2 gives us 3. 2 here, 2 cancel that. So 2n equal 3 minus 2, and this will give us 1. 2n equal 1. So dividing 2 by 2, n equal half. You will see that we even solved this problem, which was problem number 1. So I just want us to go through so that you get used to it. N now is half, right? So let's proceed. This is to tell you that gamma 3 on 2, gamma 3 on 2 should give us 3 on 2, um, 3 on 2 gamma half plus 1, right? Because we already solved for, we know that half plus 1 will be the same as gamma 3 on 2. So comparing this, we have to solve this one again, comparing it to this formula right here. Our n is half. So this is going to give us 3 on 2, n, which is half, right? Gamma half. Is that clear? So going further, we know our gamma have to be a constant. So simplifying the fraction, 3 by 1 will give us 3, 2 by 2 give us 4. And gamma half is square root of pi. Square root of pi. So this is our final answer, 3 square root of pi on 4. I have a shortcut for solving this, but let's look at the next last example under this. Our third example is to evaluate gamma 11 on 2. So this one we have to do it up to the extent that we can get a constant. Generally, that is how we are. That is what we are supposed to do. So we want a certain number that if we add 1 to, it will give us 11. Like we did earlier, you can use that same procedure to find it out. Immediately after this solution, I will show you a trick of doing this. So you can see that this one is the same as 9 on 2 plus 1 will give us 11. So since 9 on 2 plus 1 is going to give us 11, is the same as gamma 9 on 2 plus 1. And we know that for gamma 9 on 2 plus 1 is going to be n gamma n. And our n here is 9 on 2. So this is comparing this formula to this problem right here. Because we are able to express the problem in this form, then we can use this formula to evaluate it. So our n here is what? 9 on 2. So this is going to give us 9 on 2 gamma 9 on 2, right? With this, you can also see that we have to go further and simplify this 9 on 2. So what plus 9 on 2, what plus 1 is going to give us 9 on 2. You can use the same procedure to solve for that. You can see that 7 on 2 plus 1 is the same as 9 on 2. So see that this is the same as 7 on 2 plus 1. So since after you've gotten this, then you go ahead and apply this formula. Your n here is 7 on 2. So you are going to get 9 on 2, which is already there, multiplying 7 on 2, gamma 7 on 2. I hope that is okay. So in this gamma 7 on 2, you have to further go ahead and simplify it. So what plus 7 on 2, what plus 1 will give you 7 on 2? So you could see that 3, 9 on 2, 7 on 2. So 3 on 2 plus 1 is the same as 7 on 2. Once you are able to break it in this manner, then you can go ahead and apply. So this is going to be n gamma n. So 3, we know that this one is already there, multiplying 7 on 2. We have n, our n now is 3 on 2, gamma 3 on 2. We are not done yet. We have to go ahead and simplify it out to a point that we can get a constant if possible. So now 1 plus what will give us 3 on 2 is half, right? So now go, these one are already there, don't forget them. 3 on 2, so we can get half plus 1. So once you are able to break this in this manner, just go ahead and apply your n gamma n, n gamma n. So you are going to get 9 on 2 multiplied by 7 on 2 multiplied by 3 on 2. Now n gamma n, your n now is half. So multiply by half gamma half. You could see that at this point, you know this constant, gamma half is the same as square root of pi. So this is going to give us 9 on 2 by 7 on 2 by 3 on 2 by 1 on 2 square root of pi. Let me just multiply this and give you the answer. This is going to give us, if you multiply everything right here, you're going to get 945 odd on 3 to square root of pi. So this is our final answer. Now let me show you the trick. The problem is find gamma 11 on 2. So don't stress yourself. Just take your calculator. Point 11 on 2, 11 on 2. So subtract minus 1 from it. Minus 1. What did you get? 9 on 2. So just write 9 on 2. Continue subtracting minus 1 from it. The next one is 7 on 2. Continue subtracting 1 from it, which is 5 on 2. Minus 1 again, which is 3 on 2. Minus 1 again, which is half, right? So when you get to half, don't forget to bring in gamma half. That is your endpoint. So when you're done, just multiply everything right here and simplify it. You are good to go. You can apply this one as far as questions like this are concerned. If you were to find for gamma 3 on 2, then you just bring in your 3 on 2. Then when you're done, minus 1, what you get to write is half. Because it is half, you can't go further. Like, just leave it that manner and bring your gamma half. Your last part, if it is half, just bring your gamma half. But if you get to a point where you are getting negative number, just stop there and bring gamma of that number. Assuming you got into 4 on 5, and when you subtract 1, you got negative number, just stop there and multiply everything and add your gamma 4 on 5 to it. You are good to go. So another practical example we have to look is this. This, we have gamma of two functions, gamma 1 on 3, gamma 2 on 3. Now to simplify this, we are going to use one of the formulas that we previously wrote so far, which is Euler's formula. So anytime you see gamma of two functions like this, let Euler's formula comes into your mind. Euler's reflection formula. And what is this formula? This formula is simply saying that if you have gamma of two functions and you are able to express to manipulate the second function or any of the function to get 1 on minus 1, then this will be equal to pi on sine n pi. So how do we make sense out of this? It means that you should have a function which n is here and 1 minus n here is like, and nothing will happen to the function that you express it in this form. So looking at this, we already have 1 on 3. Let's try and see what we can do to get to what we can do to simplify this. So we have gamma 1 on 3, right? And we also have gamma 2 on 3, right? So we are trying to look at something like 1 minus something to give us, let's say, 2 on 3. So let's solve this problem. So multiplying 2 by 3, we are going to get 3 minus 3 and equal 2, right? So if this 3 should cross, we are going to get minus 3 and equal negative 1. This 3 crossing here. So at the end of the day, let's divide by negative 3. So we are going to get our n to be 1 on 3. Can you see that? It means, looking at this, you could see that 1 on 3 here, 1 on 3 here. I'm coming. So you can see that even if you created 1 minus n equal 1 on 3, which is which is this one right here, we are going to get 2 on 3. So you can see that 1 minus gamma of 1 minus 2 on 3 multiplying gamma of 2 on 3. So you can go ahead and apply the formula. So like I told you earlier, if you see two gamma functions like this, think of Euler's reflection formula first, all right? So let me show you another trick of also knowing how to do that. We need 1 minus something equal, we need 1 minus something so that, I'm coming. So you see, we have 1 on 3 here, we have 2 on 3 here. So you can just take 1 minus any of these. You see, you are getting 1 of 3. So when you are done, just bring your this value here, like 1 minus your answer, right? You'll see that at the end of the day, your n value will be the same. So you can just go ahead and apply that. So I've decided to use gamma of 1 on 3. So gamma of 1 minus 1 on 3. Because this and this are this. If you simplify this further, you are still going to get this one, nothing changed. So this will be equal to pi over sine n, right? N right here, comparing this to this formula, n right here is 1 on 3. So 1 on 3 pi. And you know that pi is the same as 180. So you can just bring 1 on 3 multiplied by 180. So punching this on your calculator, whatever you get, then you take sine of that. So 1 on 3, you are going to get 60. So 1 on 3 pi is 180 multiplied by 180, you are going to get 60. So this one right here is equal to pi over sine 60. And what is sine 60? Sine 60 gives you root 3 on 2, right? Can you see on the calculator? Should be pi on root 3 on 2, right? So let's further break it down. So I can write pi, let's say, divided by root 3 on 2. Because I want to take off my division sign, this can be multiplied by, if I bring multiplication sign, I have to turn this term upside down. So it's going to be 2 on root 3. And this is going to give us pi multiplied by 2, which is 2 pi all on root 3. So this is our final answer. So I hope that makes sense. So keep it in your mind. If you have two problems like this, let your mind go to Euler reflection formula. Look at how the problem is. Now let's look at gamma of negative numbers. With this one too, this is a fraction problem. And like I told you earlier, when it comes to fraction, we have to use this formula, right? Gamma equal n gamma n. But in this case, for negative fractions, we have to make gamma n the subject. So making gamma n the subject, we have gamma equal n gamma n. So we just divide both sides by n so that n will take care of n. Then at the end of the day, we get gamma n equal n plus gamma n plus 1 all on n. So for negative fractions alone, please don't forget to use this formula. It will make your work easier to solve for gamma negative half, right? So gamma negative half, like I told you earlier, we are going to use gamma n equal gamma gamma n plus 1 all on n. So looking at this formula, our n here is minus half. Don't let this confuse you. When we are dealing with negative numbers, just follow this procedure. Make sure you use this formula by making gamma n the subject in the formula that we use for fraction problems. So now our n equal minus half, right? So gamma half. Wherever we see n, we replace it by minus half. So we have here gamma minus half plus 1 all on minus half, right? So for negative problems only, you are able to simplify this. So minus half is the same as 0.5, right? Plus 1 is going to give us what? Half. So this term right here becomes half for negative problems. So gamma half all on minus half. And gamma half is a constant which is square root of pi. So it's square root of pi over minus 1 on 2. So how do we simplify minus 1 on 2? This one we want to multiply to, so just let's turn it upside down. We're going to give a minus 2 on 1. So at the end of the day, we are going to get minus 2 root pi. So this will be our final answer. You can also keep this one in mind. So gamma negative half is equal to minus 2 root pi. Unlike gamma half, positive half, which is square root of pi, gamma negative half is minus 2 root pi. So let's look at another example, last example on this. gamma minus 3 on 2. So now let's follow the same procedure. No, for negative fractions, we are going to use gamma n plus 1 on n, right? Yes. So here, gamma minus 3 on 2. We just substitute wherever we see n, we substitute by minus 3 on 2. So gamma minus 3 on 2 plus 1 all on minus 3 on 2. And this one we are allowed to point it on our calculator and simplify. So minus 3 on 2 plus 1 is going to give us minus half. So this should be equal to minus gamma minus half all on minus 3 on 2. And from our previous example, we know that gamma minus half is minus 2 root pi, right? So we are allowed to also substitute this in order to not to waste time. So minus 2 root pi. We know that gamma minus half is the same as gamma 2 root pi. So all on minus 3 on 2. We want to simplify this further. Let's multiply by reciprocal of this, which is minus 2 on 3. So at the end of the day, we are going to get multiplying minus 2 on 3. So minus minus will give us positive, right? So 2 by 2 will give us 4 root pi all on 3. So this will be our final answer for this problem. So how do you solve this problem? You see, we also have standard table for gamma function. So you can refer to gamma table 0 to find the value for gamma 0.2 and gamma 2.3. But in cases where you have a gamma 3.5, there is a formula you can use to simplify this further. And 0.2, you can just also go by the normal way. Sometimes it can be tedious. So normally you'll be given problems which you can solve easily. So let's try this 3.5 something. This question, like any question like decimal problem that involve 0.5. Remember 0.5. When it is 0.5, you can use a certain formula to break it down. So and this formula is gamma n plus half should give us gamma 2n root pi all on 2 to the power 2n minus 1. And you know that if you are to simplify gamma 3.5, you know that is the same as 3 plus half, right? 0.5 is the same as 1 on 2. So the same as 4.5 is going to give us 4 plus 1 and a half. 20.5, as far as it's 0.5, then it's going to be 20 plus half. So you express it in this form, then you therefore compare your n value and substitute it here. So if we are to solve for gamma 3.5, like I told you earlier, this formula is applicable only when we have 0.5 problems. So this 3.5 is the same as 3 plus half, right? So you can go ahead. Now your n is 3, not the fraction. The half is just something that is there. So your n is 3. You are going to get gamma 2 by 3 and square root of pi all on 2 raised to the power 2n. Our n here is 3. So 2 by 3 will give us 6 minus 1 will give us 5. So simplifying this further is going to give us gamma 2 plus 3 is going to give you gamma 6 root pi all on 2 to the power 5. And 2 to the power 5 is going to give you, for this formula, you have to also get gamma n here, right? Sorry, I forgot to add. They are multiplying. So gamma n here. Sorry, gamma n. And our n is 3, right? So gamma 3 should be here. So it means that This is the actual formula. So when you have a point half problem, so this is going to give us gamma 6 root pi, the square root of pi, all on 2 to the power 5 gamma 3. And from our previous examples, we know that for gamma n plus 1 equal to n factorial, this is when we are dealing with terms which are not fractions. So it means that if we have gamma 3 and we are able to express it into 2 plus 1, 2 plus 1 is the same as 3. So we just make it this way, 2 plus 1. Then we can simply say that uh, the solution for this is the same as 2 factorial. So if we have gamma 3, you can say gamma 3 is the same as 2 plus gamma 2 plus 1, which is equal to 2 factorial, right? So the same, you can also do the same for gamma 6. Gamma 6 is the same as gamma 5 plus 1. 5 plus 1 is 6, so 5 factorial. So if you simplify this, you are going to get 15 on 8 pi. So this one right here, we know that gamma 3 gives us 2 factorial, gamma 6 gives us 5 factorial. So replacing this by 5 factorial and this by 2 factorial, which is right here, 2 factorial, which is right here. Then 5 factorial with pi, square root of pi, all on 2 to the power 5, 2 factorial. When you simplify this, we should get 15 on 8 pi. So that is it for this video. Now that you know this, in our next lesson, we are going to now dive into what is expected of us, like how to use this idea to simplify um, integration problems. So thank you for watching. See you in my next video.